Hello and welcome back to Project Java. This is Venkat, and in this video, we will be talking about data types, variables, and arrays in Java. Now, this is something really important to learn because from this part of the course, even missing one video of this course would get really hectic for you to understand the rest of the topics. Since this course is totally aligned according to whatever we teach, we'll give you the problems and assignments in the subsequent lectures. So missing out from here would be a great setback to your Java learnings. So I would suggest not to skip any single point from these videos because it will be having something which is really new and which you might not have been aware of all this while. So I wouldn't ask you to skip this video. So please watch it till the end. Okay, talking about data types, variables, and arrays, we would be discussing what are primitive and non-primitive types. We would also know about the typecasting and evaluation of expressions. Then we'll have a loose talk on data types, variables, and identifiers, something which is new, the local variable type inferencing. We'll learn how to instantiate classes using the new keyword. We'll also learn how to read user input. And at the end, we'll talk about the arrays in Java in detail. Moving on, what are data types in Java? So basically, data types are the type of data a variable can hold, which is pretty simple to understand. We have already discussed what a variable looks like. Well, let's say this is a jar and I pour in some water and fill this jar. So the jar becomes the variable and the water becomes the data type. So basically, variables are containers, and what type of containers you want to specify, that is where data types come in. Knowing this is really important because Java is a strongly typed language. You should keep this in mind. Java is a strongly typed language. What does this mean? It means that every variable that you declare, every expression that you create, any mathematical expression, they all need to have a data type. And that data type would be again checked for its type compatibility. It's not that, let's say, just a second. So checking for the type compatibility, uh, let's understand this with the help of an example. So let's say that you have been given a water bottle. Okay, let's say that you have been given a water bottle and you store in, some gas in it, like any kind of gas, let's say nitrogen gas or oxygen gas. Well, that would be pretty useless, right? Why? Because if you had to store a gas, you need a sealed container instead of a water bottle. If you store water in the steel container, like sealed container, and a gas in a water bottle, it everything would go haphazard. So this is what type compatibility talks about. It says that given a container, let me just mention it here. Given a container, you should specifically use it. You should specifically use it for the type of thing it can hold. So this is what type compatibility talks about. So given a variable, you should specifically use it for the type of data it can hold. Okay. So there needs to be two things. That is, every variable expression must have a data type, and secondly, all those should be type compatible. So given these two things, only then a Java program would compile successfully. Otherwise, it will throw errors, compilation errors. Now talking about Java, Data types can be classified into two sections. One is the primitive type, which you cannot create objects of, and the other are the reference types or the non-primitive types. Okay. Well, I have also heard that these non-primitive types in some books are also being referred to as object types. So either way, it's correct. Now, these primitive types are used for basic purposes, and you cannot instantiate them. So primitive data types cannot be instantiated. The main reason why they cannot be instantiated is because of efficiency and their usage. Well, they have a very extensive usage. You should note this. There isn't any single program that you can write without primitive data types. It is said so. And efficiency, because object creation takes time in Java. It allocates some memory to the on the heap, and then accessing it constantly and modifying it and changing it, alterating the entire process takes a lot of time. It consumes a lot of time, and that is why primitive data types were kept separate from the reference or non-primitive data types. Well, this is one of the reasons why there is a question whether Java is 100% object oriented or not. This is a very famous interview question, but we will be talking about this after completing the reference types as well. So I'll hold up this question for you as important, which you should note. Let's move on to understand what are primitive data types. So primitive data types can be understood as the most important data types that you use, in your everyday programming in Java. So there are a set of eight primitive types. Okay, there are eight primitive data types that you use, and I'll classify them one by one. There is, let's say, this is the primitive data type. So there is one section which focuses on the numeric types, and there is this another section that focuses on non-numeric types. Okay, now numeric is further branched into two types, which is integral and floating point. Now, I know that you know about all of this, but it's good to revise these concepts once again in this video. And in non numeric types, there is a character type, and the other is a Boolean type. Okay. Now, these integral and floating point are further branched into different data types. So, if I write all of them at once, floating point has float and double data types. And integral data types can be classified into four different categories once again. One is the byte data type, second is short data type, third is the int data type, which is widely used, and the next is the long data type. So, in total, here there are four and five, six, seven, and eight. So, there are eight primitive data types in Java. Now, all these primitive data types are signed. All primitive data types are signed except Boolean and char. Okay. Now, what does this word signed means? Well, this means that they carry a unary positive or a unary negative sign with them. For example, if I had to store a number, let's say minus 21, I could go with the byte data type as well as short data type as well as int and also long data type. Preferably, I would go for a byte data type if I had to just store this minus 21 or a int as well. It would work well with it. Let's say that I had to store plus 932. I would definitely choose the short data type, but also most preferable and used int can also go along with it, as well as long. But to save memory and to follow the stereotypes, I definitely go for an int data type. So this is the meaning of signed. Signed means it can hold both positive and negative values. Okay. Now let us discuss about the byte data type at first. You must have heard about this, that one byte is equals 8 bits. Okay. Simple calculation, bit manipulation, and this is really simple. So for a byte data type, the allocated size in Java is literally 1 byte. And the range of numbers that you can store into the byte data type is from minus 128 to a positive of 127. Which means if you store a number which is greater than positive 127, it will give you a compilation error. Or if you store a number which is below minus 128, it'll give you a compilation error. Okay, it'll simply mean that it has overflown. So minus 128 is the minimum value that a byte data type variable can hold, and plus 127 is the maximum value that a variable which is of a byte data type can hold. Now how could we understand this? Okay, I just explained to you that 1 byte is equals 8 bits. So let's create some rectangles and work it out. So I said 8, right? 1, 2, 3, 4, 5, 6, and 7. Right. Now let me number these, like based on the LSD and MSD. No, not the drugs, but the index values and positions. This is 2 to the power 0, 1, 2, 3, 4, 2 to the power 5, 2 to the power 6. And well, this is the most significant digit. Okay, which means in this particular place it will be either plus or a minus which will be stored. So 2 to the power 0 gives me 1, 2 to the power 1 gives me 2, and then it gives me 4, then it gives me 8, then 16, then 32, then 64. So what am I getting here? It's a positive 127. Pretty amazing, right? Gives me a positive 127. But how come the range here is one, less than the range here? Why is it minus 128? Why not 127? Well, here's the reason. When a when a binary number is positive, it is pretty simple to denote the sign bit with a positive sign. Like 0 can be used for a positive sign and 1 can be used for a negative sign in sign bits. Okay, this is the sign convention. So basically, this particular most significant digit stores either a 0 or a 1. You should note this. Now, in case of a negative value, for a negative value, computer takes negative as 2's complement. So, since it is represented as a 2's complement, you have to go a little lower in the minimum value. Well, that's the computer that we are using and not a Java concept, but it is a good to know thing. Also, one more thing that I would like to mention, all data types throw this, like error, which is possible loss of precision. When does this happen? When the range of one data type, is less than the other data type. And then you simply leave it to the compiler to decide what type of value it can produce with it. In these cases, to avoid these cases, there is explicit typecasting, which we will learn very soon. Okay. But just to have this thing in your mind, you should always know that it can give you a possible loss of precision. Okay. Now, let us move on. Let me just add another page into it. Okay. Right. Now let's talk about the short data type. Another very important data type. It is basically, I mean, I was kidding. It is rarely used in Java these days because it was built for, like 1995 processors which used 16-bit methods, especially the processors if you have heard about, like 8085 up or 8086 up. So these are some processors that use 16-bit methods. And for that, short data type was used because at that point of time, read write things became easier with the help of short data type. This is very important. But right now, 16-bit processors are outdated, and hence short data type is really not used that much. So, still it's good to know about the size, which is 16 bits or 2 bytes of data that it can store. And the range for short data type, I think, is -32768 to a positive of 32767. Now, the same reason applies here as well, that um, the most significant bit acts as a sign bit. So, and always a computer takes negative as a two's complement. So that is why there is that one uh, 8 that you are seeing here, not a 7. Now, let us know about the really important type in Java that we use very often, which is the int data type. Now, let us know about the most used data type in Java, the most commonly used data type, that is int or integer type. It's like literally you cannot write any class in Java without using this int type even once. That is the folklore that goes, but it's okay. We can always use the other data types just for practice. So for the size of an int data type, it is 4 bytes. Okay. And it has a pretty big range in which it could store the values. So it is -21,474,836,48 to a positive of 21,474,836,47. This is the range of an int data type in Java, which means if you write something like this, int xyz is equals 21,474,836,48, you would definitely get a compilation error because the maximum that you can have is a positive of 21,474,836,47. So a compilation error saying that integer number too large would be generated, which you should avoid. I mean, in simplicity, you can also remember the range to be a negative of 2 to the power 31 to 2 to the power 31 minus 1. Okay. So this range you can keep in mind pretty good, pretty well in your mind. A negative of 2 to the power 31 to 2 raised to the power 31 minus 1. All right. Although you might think that using a byte or a short would be more efficient than using an int in situations in which the larger range of an int is not needed, this may not be the case. Now, here's the reason why. The reason is that when a byte and short data types are used in an expression, when they are used in an expression, they are promoted to the type int automatically by the Java compiler when the expression is evaluated. Therefore, int is often a best choice when integer is needed. So, I mean, you could definitely think about using byte and short in an expression, but the best choice when it is an integer is the int data type. Now let's come to another data type, which is long. Sometimes int is not enough to hold big values, and there is where we should go for a long data type. We can understand in this way that let's say that you need to store the amount of distance traveled by light, you know amount of distance traveled by light in 1,000 days. So in order to hold this value, an integer type is not sufficient. It will overflow. So, you write something like this in that case. Long L is equals the, speed of light. Let's say it's 126,000 kilometer per second in times 60, you know, and oh, I mean, this shouldn't be 2, it should be 8. My bad. It is 186,000 miles per second, if I'm not wrong, times 60 times 24 times 1,000. And this value would somewhere result in, you know, it's a big value. I just remember the start, let's say 16070 4, and then there is some number of zeros more, and then miles. Okay, so like this huge value, an integer type cannot even store. It'll just give you a, compilation error saying that the integer number is too large. The the Java compiler would be like, brother, this is not my type. This belongs to somebody who is of a higher order than me, and thereby it goes to the long data type. Now, you'd be surprised to know how many bytes a long data type can store. Like, what is the size of the long data type? It is 8 bytes to be precise, or 64 bits. But if you ask me, how do I know that this expression would evaluate to something which would be in the range of a long data type? How would you justify that? Well, I know the range. It is a negative of 9,223,372,036,854,775,808 to a positive of 9,223,372,036,854,775,807. So this is the range of a long data type. Well, this is no magic, or I'm not referring to any book at this point when I'm talking to you in this video. You can remember it pretty simply. I just use this concept that I separate the first digit out, and then I remember the sequence of threes. And then, I just write it that way: 9,223,372,036,854. And if you see, the only change happens here and here. So you just need to remember one part of this, and you'll be pretty fine. Now, this is not asked in the interview that what is the range of a long data type. People would go crazy and would actually go to, kill their own interviewers and recruiters. So this is not asked. But it's good to know knowledge. I mean, general knowledge type of thingy in Java. So this is what integral types look like. Now talking about floating types. What are these types? Do they really swim when they are let out in water? Uh, I'm sorry, they don't. Floating types, it means that numbers which are assigned, like attached with decimals. Let's say that there is some fraction that has been given to you, 3 by 4, and you evaluate it to get 0.75, right? So a number which has decimals with it cannot be stored in an integer type. It has to be stored in a floating point type. So this is where you would store it. We discussed about two data types, which is float and double. This is exactly where you would be storing the floating types. So let's discuss them one by one. Uh, Let me just copy this. Yeah, better. I forgot to remove it. Yeah. Now let's talk about the float data type. Now float is just like byte and short. It is used to store single precision floating values, floating point values. And if we talk about the size of the float data type, it is of course 4 bytes, and it has a range of oh, I'm sorry. It has a range of, I suppose, a negative of 1.7 E32 to a positive of 1.7 E32. Now you can really evaluate it. I don't properly remember what's the range for float and double, but I suppose this should be the one. And when you declare a float variable, you should say that float some variable name, let's say ABC, is equals 10.21 f. Now this f is really important to mention. Otherwise, just like we had seen in this particular slide with int, that byte and short are automatically promoted to int. All the floating type variables are automatically promoted by Java to the double type. They are automatically promoted to the double type, like the double data type, by the Java compiler. So you need to mention this f in order to s- tell the compiler that it's a floating point. It's a float value, and it's not a double type double data type value. Okay, float can be useful where you don't need a large degree of precision. Like currency things can be represented in float. So somewhere where you don't need a large degree of precision, you can use float easily. you know Single precision is faster on some processors. Like it's considered to be faster on some processors and take half as much of the space as double precision. But then it'll become imprecise when the values are either very large or very small. This is one of the famous Oracle certification questions, where you would see an ambiguity in the float data type and the double data type in case of a like iterative structure. We will talk about that, but before that, let us know about the double data type now. The sixth type, which is the most used when there is a floating point requirement, is the double type. It's the most commonly used for storing floating point values. Okay. Now, with the name itself, it's just like a representation of the long data type, but for the floating values. The size of this data type is 8 bytes, or 64 bits, and to be precise. and it has a double precision, which means it has a higher degree of precision. The range of this data type, as I said, I don't remember properly, but it should be supposedly 3.4 e to the power 6 e64 to positive of 3.4 e64. So I think this is the range of the double data type. For, you know, this double precision is actually faster in some processors. This is something noteworthy, and it's more accurate than a floating point because some modern processors, they have been really optimized for high speed mathematical calculations, and for that, you know double precision is actually faster than single precision on some modern processors. All the functions, math functions that we are going to see and talk about, like sine, cos, and then sqrt, all these methods, they return double data type values. So it is actually faster on some processors because some modern processors have been optimized in order to handle double type. And this is where we finish off with the floating point types. Something special, the seventh data type, which is the char data type. Now, some people pronounce this as char, or they pronounce it as chor, but I mean, it's okay. You can always pronounce it as char or whatever you want, unless you misinterpret its meaning. In Java, the data type which is used to store characters is char. Okay, it's based on Unicode. So, what is Unicode? Unicode is an encoding format. It's a encoding format used for, this is an encoding format which is used for representing all characters, numbers, tokens, digits, symbols, etc. uniquely. It's a 16-bit encoding format, which is known as the Unicode. Before this, there was ASCII, okay, but ASCII was then super ruled by Unicode because it included ASCII within it. So yeah, the range of a char data type is from 0 to 65536. Now you might have a question, why 0? Why not a negative value? Well, a character in Unicode cannot have any negative values, okay? Unicode characters and Unicode numbers, they all start from and range from 0 to 65536. So basically the size of a char data type is 2 bytes or 16 bits. So it does not fail the Unicode standards, and that is why this range. At the time of Java creation, Unicode required 16 bits, and thus Java char is also a 16-bit type. There are no negative characters, as I said you. One more thing which I would want to mention and I would want you all to note down is the fact that Java treats all characters as numbers internally. Pretty shocking. They treat all the characters as numbers internally. But this is the truth. And that is why when we would learn in typecasting that we can actually typecast pretty easily any character to any integral data type, it'd be easy for conversion. So, let's say that you say that char ch is equals 127, okay? So it would actually, give you the character whose Unicode value is 127. it would give you the Unicode value of that character whose value is 127. Like just for a sake of example, if I write char ch1 is equals 88, so the character that you'll be getting that ch1 will display on being printed is y, capital Y. So yeah, that's the thing. And like you can even have increment operations on this one. Let's say you can write ch1 plus plus, and when you try to print it, print ch1, you would get a capital Z. That's the magic. I think I just made a mistake. This would be 89 instead of 88 for ch1 to be y. Yeah, now that's cool. So now when you increment this 89, when ch1 would become 90, it will give you a capital Z. Now let us know about Now let us know about the last data type on our list, which is a Boolean type. You don't write Boolean as B capital because B capital means a wrapper class. It's rather written as Boolean B small in lowercase, entirely in lowercase. So the size of a Boolean data type is 1 byte, but the used space is only 1 bit. Why is it so? Because Boolean has only two values. It can either result in true or can result in false. That's it. So there is nothing known as range for a Boolean type. And Boolean in general, um, basically is required for conditional expressions. So when we'll learn about the control flow, we'll get to know about Boolean data type in detail. That's it for this video. In the next video, we will learn about literals and constants before jumping into, typecasting. We'll also see some code examples of data types in use. We'll create some variables, we'll play around with them with some operators and all. So don't forget to like, subscribe, and share. And I'll see you all in the next video. Thank you.